So I'm going to show you a somewhat quick workflow to like get like a point cloud or topography from LiDAR into Rhino. There's like a couple of methods to do it. One way to do it, and I think I discussed this at the last workshop, was downloading Lance Design. So if you don't have that right now, that's okay. You just like watch the process. But through Lance Design, there's like that vegetation library that it gives you. So sometimes that's helpful, maybe not. But there's also this like tab called terrain modeling. So inside that tab, you can go to import Earth elevation data. So this is using like Google's satellite topo. It's not that accurate. And I'll show you what that looks like. So what you can basically do is like search any device, and typically they have data. If you're on Google Earth and you put like show topography and there's no topography, it's going to so the example I'm using for this workshop is like Fairmount Hill. So I'm just going to do like a really quick import. And you can basically tell it to just import everything within the image. So if you just zoom in, you press import, and then create a mesh. So it's like a really fast way of going about like bringing in, topography. So as you can see, like that's like north towards the Willamette. And just to show you like some commands that are helpful, there's contours. Contours is a really helpful command, just because it literally splits them all and shows you contours, and you can specify intervals here, and that's done by distance. So if you're working in feet, you want to show like a 5-foot interval. You just type 5 feet and then press enter, and it'll start to like create that topography. So this is like kind of like the method you would go about generating topo. And as you can see, I'm going to hide the mesh, so I'm going to use the command select mesh. And that's another thing too, just as a side note. If you want to select something, like the code word is SEL for cell, and you can select like any object. And Rhino's actually really good about that, because with other programs, it can get hard to select certain objects. But if you know that you have a mesh in there, you can just type in cell mesh, and it'll select the mesh for you. So very like command heavy program, kind of like AutoCAD. I'm going to use command hide to hide that. So there's also a terrain model. So this is from Lance Design, so you can hide that if you want to too. So this is kind of just like the base contours, and it's not like the best. It's not showing maybe some details we would want. So if you're really looking for a quick, easy way to get terrain, that's one option. Another good option is using NOAA's data access viewer. So in here you can look for like digital elevation models. I'm sure we're going to use it in Chris's GS class probably. I learned this from June's class in LiDAR. But if we were to go to like Eugene, Oregon, so here's Eugene, and you wouldn't really specify a whole area like this unless for some reason you're working in that area. But I'm going to go back to like Fairmount Hill and just use this draw tool. And from there, we can like select kind of the scope of the project there. And if you want to follow along, you can. The website again is coast.nova.gov, and then from there you can go to the data viewer. Sorry.
Search to like NOAA LiDAR data
On Google.
And then I think you can get to it that way, yeah.
Okay. Yeah, so do that in Google. Data access viewer, there you go. And then from data access viewer, you can go to that elevation. Thanks. And then you can type your area of interest. Not huge, but. So again, going back to this area, once you like select your draw area and you're in this elevation tab, you'll see that there's like these different dates when LiDAR was done, like throughout the county. So you know, I think just choosing one that's like up to date, like this LiDAR like County Oregon is probably the same as this one. So what you do is you just say like add it to your basket, and then from there you can go to your basket or your cart or whatever. And this gets like a kind of really specific, and I'm gonna go through this quickly just to like save time, but what you want to do is you want to specify your output product as points. So you're getting a point cloud, and these are LiDAR points. And you want your output format to be an ASCII2. And that's just like kind of file-oriented things. ASCII files are text files, and they come in like XYZ points. So another thing you want to specify, if you just want ground, you can specify ground, and Node will only give you the LiDAR points that were generated from the ground. If you do all, it will pick up what's called a digital service model, so it's like the whole entire area, including trees and buildings. So you do that, you press next, you put your email in, and it's going to take some time, so I shouldn't have closed that.
If you did give the all, and you had the trees and everything, would that be feasible to work with if you were in a situation where you wanted the trees and everything?
Yeah, you can get all, and then you could also get the ground, and you could like subtract them just to get like what's above ground. So that can be helpful sometimes. Yeah, and so it's going to email you as digital codes, and when it's happening, it may take like a couple minutes. So again, don't worry about following along right now, but it's going to give you this like download link, and usually they're like kind of big. This one's only like 76.3 megabytes, but you can get points up to like over like billions of points to your point cloud. And yeah, sorry this is so specific, but I think this is kind of helpful to know. So once you get that link in the downloads, it's going to be this folder, and there's going to be all these text documents in there. And this is like very like just obscure, but this is what the ASCII2 file is. So it's an XYZ coordinate system. So all you have to do in Rhino is go back to the interface, type in import in the command line, and go to your folder. And this is really annoying, but you have to one by one import these. There is a Python thing that you can create to do it like automatically. It only takes like 5 minutes to import all of them. But one thing to specify is create point cloud and make sure it's comma. And the reason why we want it to be comma is because this text file is delineated through commas right there. So it's just telling the program to read those points as like different points or different XYZ coordinates. Then you press OK. What that's going to do is it's going to give you a section of your study area. So again, you have to go through and like basically import all of these point clouds, and it takes 5 or 10 minutes. It's no big deal really. But what you end up getting is like a giant, you know, your study area that you like kind of selected from LiDAR. So you know, again, you're not really going to like ever probably working on like an area this big, especially for topo. But like let's just say you're working on like the east side of Fairmount Hill, and you wanted to create a mesh from that. So you select this point cloud, and the command you want to use, and this is kind of important, is mesh hash. And what that's going to do is it's going to take all of these points and create like a triangulated mesh from them. And it's going to take a second to calculate. So I'm going to select the point clouds, remember using that cell command. I'm going to hide them now. And as you can see, it's like a super detailed mesh. So when we compare it to the Google train, you know, it's pretty different. Like there's not as much detail for sure. So if that's something that's really interesting to use, like catching detail, I would recommend using this process. And I'm going to contour it really quickly. So again, using that contour command, and I'm going to specify the base point, which could be like anywhere on the z-axis. Holding shift, just pull it up and press, just so you're telling it to go on the z-axis. And I'm going to specify like 10 feet. And you'll begin to see that this topo is actually showing like roads. You can kind of see that like right through here. Or it may not necessarily be a road, it definitely looks like some type of like path, or like maybe where water would kind of be collecting and moving down in this like valley. So that was like a super, super fast like kind of intro into topography. Does anyone have questions right now? does that like all make sense? Have you like ever worked like with like surfaces and creating contours before? No,
Not in
right?
Rhino.
Not in Rhino.
Yeah.
Okay.
Also, what is the term point cloud refer to within Encompass?
Yeah. Okay. So the point cloud is literally these. So it's probably really obscure. So like these are like literally points. And what this is it's like from an airplane they're shooting lasers at the ground, and it's literally like measuring its reflection and telling the program like how far the point is from the plane, and it creates this drape of the Earth. So what we got from LiDAR was just ground points only, but as you can see there are these holes which are most likely like houses. So you can always get that data included. It's going to increase your point load, which will make your files slower, but yeah, massive. But again, this is like a huge area. Like even this, like this one point cloud, because I think I have like this whole entire area. Like you would never really like need that much space. But I just kind of wanted to convey like that Rhino's pretty like fast in the sense that it can like kind of calculate all this stuff. Yeah.
Did you use this process to create your sections for ecology?
I think I used the land process. So I used the elevation tool for terrain modeling.
Okay.
Just because I didn't really want, like, I don't think it needed to be that specific, but
Okay.
I think this is really helpful. Like, I feel like when you're in an office, you're like working with like a team. Like, you'll probably have like civil engineers like give you that topography, and you know you'll work with it. But if you're like doing a competition or something, like it's probably helpful to know this because you may not be in a team at that point. So you may want to like be able to like develop your own topography and like show like how you can manipulate it to get a certain idea across. Yeah, I'm trying to think if there's anything else with this process.
Did you go through the SketchUp import?
So I went through the Lance design.
Okay,
import.
okay.
Yeah, so you can do it through SketchUp, and it's like really easy if you look online. There's like some videos on it. You're basically like using Google's system again to like import it. And what's nice about SketchUp is it like brings in the aerial imagery, so that can be helpful. Lance design used to do that. And I don't know why they stopped, but.
So if we're using a trial right now of Rhino, are we able to get plans design?
I think
Do we
so.
pay for it, or do we just add it as a?
Yeah, it's free. It's in beta right now, so it's
Okay.
still free. Yeah. Yeah, and again, I can show you really quick what that interface with Lance Design is. So, you know, you have these different tabs. You can create fences, stairs, but you know, vegetation is what's kind of interesting to me, at least about it, because you can look through a whole catalog of different plants, and it's pretty Eurocentric, but there's some plants in there that we can use, and you can kind of select them, and then adjust their height or their age, which I guess there's some type of algorithm that's telling you how big it will be in terms of height and width. You can just like kind of, you know, stamp it in essentially. And another important tool that I think is helpful to know is the zoom selected tool. So if you like stamp something in and it's like really far away from the rest of your model, you're like, how am I even gonna get there? You can use this tool, so it's going to just zoom to the selected object. And some other helpful tools here is like zoom extend, so to go back towards like the whole entire extent of your model. So the standard tool pane here is like pretty helpful with those tools. And just as an aside, you can find like more curve tools, surface tools, and solid tools within here. I think Rhino 6 made better interface decisions with how you can go about making things. So again, I'm going to do the zoom. And also use this tool command. So zoom selected, and yeah, that's the model of the tree. It doesn't render this like horribly, like it actually looks like a tree. Yeah, so that's just like a quick intro to land. One thing we can do is go over like, you know, you take this mesh. So I'm going to select the point cloud and hide that. Oops. So you have this mesh, and you're like, okay, I'm working in like on the peak of the hill. So it's kind of hard to see it here if you change your view to rendered, which was a mistake because that may take forever. Shaded, yeah. So let's say you're like working in this area, And you're like, okay, I don't really need all this excess kind of topography, but I'm going to use a command called drape, and that's also pretty helpful to know. Because what that does is it's going to create a blanket, essentially, over a section of your model. And I'm going to go back really quick and do it again. So when you're specifying your area of your drape, it's also giving you this dialog to like adjust certain elements of it. So spacing is just talking about what's called UV spacing. I can point that out to you, but the UV spacing is essentially like the grid. So that's like the tightness of your surface. So the less UV you have in there, the tighter it's going to be, and the farther that distance is going to be, the more loose it's going to be, and it's really counterintuitive. But you can always play with that tool. So again, adjusting your from 20 to 5, and you'll be able to see that this new group is much tighter than the other one. So I'm just going to hide these. I really like the tool hide. It's like really helpful because just as an aside, you can always press Control Shift H, or you can use the display, or sorry, the visibility toolbar to show like things that are hidden. So you can like show objects, so that's everything that's hidden. But going back to this drape. So now that you've made a drape, this has been converted into a surface. And I kind of went over in the first workshop like the differences between meshes and surfaces, but surfaces are just like much more editable. So if you wanted to adjust like an area of this surface, there are a couple tools you can use to do that. So the first tool that comes to mind is like the points on. So what that's going to do is it's going to turn on all of the points of these UV like squares essentially. And if there's like an area that you're interested in like manipulating, you can kind of just select those points. You can like move those up and down. So it gives you some, I guess, I mean, that's kind of like a table, I guess. I don't know what to call that, but like you can kind of go through, and this is like really a tedious way of modeling, but like you can kind of go through and like, if there's something really specific that you want on your surface, you can always do something like that. If I were like making like a grading plan and really manipulating my topo, I would probably do the mesh patch all over again, so creating like a new point cloud from like all of the contours that I created from the original. And if I had more time, I'd show you like what that would look like. But so that's like one way of adjusting your surface. There's a couple of tools that do it. Another way is the soft edit surface tool, and what you can do with that is you can basically select a surface. So you select the surface and you use soft edit surface. And you can basically start to pull on the surface essentially. And you can like adjust the strength of that pull. So this is like, again, really specific. You may never like be doing stuff like this unless you're interested in like kind of landform and stuff like that. But you can use that tool as a way to manipulate your surface as well. And if you wanted to like see what that looks like in contour form, you can just come back and run the contour command. And you know, you have your little like conical shape thing going on there. So like those are like probably the best tools to use in terms of editing. If I were to like be again like doing like a real like grading plan or something, I would probably just make the contours from a base model. So what we have here, 5 feet, and then I would actually just either kind of just draw on top of those lines. So like we learned in our grading class, like if you wanted to, you know, kind of create like a terrace over here, you can kind of like do that, kind of working with that line. And as you'll see, like it's gonna kind of go down to the construction plane. So this is just stuff that you'll like have to kind of play with over time, but that's normal. The program wants to automatically attract your lines towards the construction plane, especially if that's off of a curve that you're using. So if that does end up happening to you and you want to flatten it, you can always use the project to C-plane command. And what that's going to do is it's going to project it to your C-plane. And unfortunately, the C-plane's all the way under here. So what I find really helpful is like when you're playing with your construction planes and you're like kind of getting all over the place, just remember you have all 4 views to your use. So you can always kind of come over here, select this point down here, and then back in plan, just move it to that curve. So that'll actually move that flat curve now onto your contour. So it's kind of tedious, but over time you'll be able to like model your stuff, and it really doesn't take as long as like once you get the hang of it. And there's definitely faster ways to go about it, but this is just like kind of a quick kind of push to get through it. But
Erin,
yeah.
this is something we went over before, but when you were hiding certain
Mm-hmm.
surfaces or objects, was there a way that you were typing the command line something and then hide rather than having to like physically select it in the window?
Yeah, so if there's something, like if there's curves, you're like, I'm gonna hide all the curves in my
Yeah.
file, you can use the SEL command and that'll open up like all of these options. So there's boxes, there's captives, I don't know what that is, that sounds weird, but you can select
Oh,
even by color.
self-select.
Yeah, exactly, yeah, which is confusing because it's like CELL, like what is that? So, yeah, whenever I say cell, everyone's like, what? So, yeah, if you do cell curve,
Okay.
that's
And then
that kind
hide.
of that. Yeah.
Okay.
And if there is like a curve you didn't want to select, like you can always, this is kind of getting into more interface things, but one way to go about it is like if you wanted to like change the color of that one, you can use like cell color. So there's like a million different ways to select things, and you know, but that's kind of one way of going about it. Yeah, so cool. I have another file that everyone can kind of follow along with, if that sounds good. It's kind of like more tools and like surface modeling and stuff like that. So let's go to that. And for those people making laser cut models, there is something I can show you that may make your life a little bit faster. It's a really weird tool. So you have your contours, and ideally you'll like have it like boxed out and it'll be like a real thing. But what you can do is you can use the shear command to basically throw your lines horizontally. I'll show you what that looks like. So what you want to do is select all your contours and use shear. What that's going to do is you're going to want to kind of just select a point and then holding shift, go up. And it lets you like throw your model essentially, as you can see here, like that. So that didn't really work. Sorry about that.
What do you mean when you say throw?
But yeah, so it's like basically picking it up, and it's hard. Yeah, it's literally doing that. Yeah, it's like just like kind of throwing it all on the table. But the reason why it looks kind of weird is because it's like not really connected by a box. But trust me, it does work. Because last term we went through it in the Platform Studio. So you kind of just select a point. It's a really temperamental command. It like sometimes doesn't want to work, and it's like super crazy. So what it's doing is it's separating all of your contours out, and you can kind of see it happening in the plan view, and I'll zoom in. It's just kind of moving it over, and you want to do it in your front or right view, because if you do it in any other view, it's going to actually like change the line. It's going to actually skew it or shear it. If you do it in your front or right view, it's probably the best way to go about it. So as you can see, it's just moving things over.
Is it like increasing distance between contours?
It is, but only on like the X and Y, if that makes sense. So it's just like literally like pushing it over, if that makes sense.
But why would you want to do it?
For laser cutting,
I don't.
it saves you a lot of time, because otherwise you'd have to go in and select like each kind of line. I mean, that's a kind of time, but you know what I mean? You have to kind of move things over.
Separate it.
Yeah, and sometimes you have like models that are like really insane, so like it would save time to get in.
So it saves us bringing them out, and then they're all
Yeah.
separated, and then all we have to do is arrange them so they fit up.
Exactly.
on the sheet.
Yeah.
Okay.
Yeah. So that's just like a random little tidbit. And if you have questions about that, like as or anything else, like feel free to ask me. But-
Do you have do you do an etching thing so you know where to place it on, like would you grab?
Yeah, what you do is you just shear it and then you copy it over like one model piece over, if that makes
Okay.
sense. And it's kind of hard to show in this example because I don't have a box. I can make that really quick, but you would just literally like copy it over. Like if you, let me just select like 5 of these and move them over. So using the control and key selecting the outer ring. So what you would do is you would just like, because the shear is equidistant and usually you have like a corner on your model, you can just copy it like over from that point. So let's just pretend that point is here. You can just like copy it over like that and it will match up perfectly. I can open a laser cut file to show you what that is really quickly. Does that make sense for everyone? You want to see the process? Okay. Let's do that. This one crazy life that do not organize anyone else. What's this one?
Well, yeah.
Cool. So I have this poly surface and it's closed. So this is like a model scale 1-to-1. So this is like 16 inches by 16 inches. And the material I was using was like 0.045 chip. So I'm just going to run that contour command at 0.045. It's going to make those contours. So this is like 1-to-1. And what you want to do is, again, do that shear command. So you type that in. So I'm going to hide this really quick. Select the poly surface and hide that. So you want to select your curves and you just shear it. You select that point, which is usually a corner, and then you just kind of start to throw your model over. It's really, like I said, like really Yeah, I was having like kind of weird issues with this one last night, but I'm just gonna pause it there. So this is still okay. It's just kind of touching itself, which sounds weird. But sorry. So if you wanted to like copy it over, what you want to do is like in your layer panel, you have like a cut layer, and you can just select everything that's going to be cut, and you can just say copy objects to layer, select the objects in that etch layer, and then just move it. And in this case, you would want to move it towards the left because the base is towards the left. So you just select that corner point, move it over,
Oh, perfect.
and then you have your etch lines on top of your cut. So
Thank you.
yeah, no problem. That kind of speeds up some of the process of laying it out. And of course, I'm gonna unhide this. These are like your 18 by 32 sheets, so you can just quickly arrange that onto your sheets and it's ready to go. Yeah, so that's one way of going about that. So going back to that other file.
A lot faster than what
Yeah. So this was like a file I used for the Artland form, so you guys are pretty familiar with it. But I kind of figured this would be helpful in terms of understanding commands that are related to surfaces, and I think that's kind of what Rhino is made for, is for like surface geometry. So again, the command line, once you get like really used to this program, like you do everything from your command line. You can use, the interface to find certain things. I always find myself like hovering over it and going, what is this? And it takes some time, but it's one way to learn. So an important thing to know is if you go to like your curves tool, you'll see like these names. And unfortunately, they don't really relate too well to like the actual command name, but you can always like get more information on it by going on that like website that I shared last time. I can go to that website again. But if you're just trying to draw like curves, you can use things like circles. If you're interested in drawing like a circular curve, you can use like rectangle to create, so it's a lot like CAD in that sense. So once you actually have like your geometry like figured out, a couple of really helpful and handy tools are these. So if you want to write these down, feel free, or if you want to follow along, that works. So if you want to like create an extrusion from a curve, the best way to do that is using the extrude curve command. So that allows you to like actually pull that curve up and create a surface, or an extrusion. So there's some slight differences there. Another helpful command to know is the cap command. What that does is it creates a solid object from an open extrusion. To avoid, if you know you want a capped object before going into your extrusion, Rhino is like really pretty good about like giving you these options like as you're running the command. So during the operation, you could just say solid, yes. You can even specify like both sides. So if you know you're at like the midpoint of the extrusion, you can do that. So always be aware that there's like this like layer of things going on like as you're doing an operation. Another helpful command, sorry, just zoom in, is your loft command. So that allows you to like loft curves together. And I know I'm just like typing these commands and things are like popping up and it's like really confusing, but what the loft is doing is it's just like extruding this curve to that curve essentially, and it gives you a seam. So you want this to be like pretty close to itself, like or in line to itself, so this looks pretty good. So it's gonna just create, a surface from that loft. You can kind of go through and do that one by one. Lofting can be really weird, it can give you some weird geometry. It's not the best way to go about creating surfaces, but it's like an option if you need to go about
Do you
that.
select all those lines and then do loft?
Yeah, so that's probably the best way to get like the most, I guess, smooth surface out of it, if you can somehow select all of your lines and do it like that. And these like weird seams, like I'm pretty sure some of them may like show up they'll show up and they may not like render. It shouldn't render as like a smooth object.
Isn't there a way to do like a smooth loft versus a rougher version?
Yeah, I think within the loft command, you can always patch, so I'm not exactly sure of the answer to that question, that's a good question, but you can patch your curves, so similar to mesh patch, it's going to take curves and create like a surface, but patching always like loses some information. So as you can see, this isn't a very accurate surface through like what we have contoured. And that kind of is a part of this process. So I think to answer your question, that's probably the one way I know how to do that, but it's not like super accurate. If you wanted to make it more accurate, you can do like